Mm-hmm. Mm-hmm. Okay, so now this, so in this triangle, this middle piece right here is going to be short leg times square root of 3. So I've got short leg times square root of 3. And I'm just going to clean it up a little bit because they're both radicals. I'm going to make this 3x minus 3 over 2. Just because I know I'm going to have to input, I don't want to get caught up in parentheses and everything else. So if they're exactly the same, yeah. All right, so this I'm going to call square root of 3x minus 3 over 2. Now I can find the area of my triangle. That was the whole goal the whole time, right? What's the area of the triangle so I can integrate it? This one is very nasty. 1/2. What's the base? And what's the height? Mm-hmm. Maybe I should have left looking at this now. Top times top, bottom times bottom, right? If I look at this, if I go backwards to what this originally was, right, it makes my problem a little bit easier because, here you go, Avery. I'm multiplying the same thing, right? So really they just, so I got square root of 3 times x minus 1 over 4. Does that make sense? Or square root of 3 over 4. I'm thinking about, I know I'm going to have to put this in my calculator or whatever. I squared what? Yeah, this 1/2 and that's okay. Anyway, I'm thinking about the easiest way for me to input this in my calculator without a whole bunch of parentheses to lose myself in, but also not doing so much work that I've made a careless mistake. All right, integrate from, it's been a long time since I feel like I looked at this curve, 1 to 3. 1 to 3. Again, I can pull this coefficient out. Now I actually have a fairly easy integral. I could do that by hand. Uh, 9 over 2 minus 3 minus. This was fun. You think I made it really complicated because I'm trying to do it by hand? Look how nice it comes out though. 4 over 2 is 2. Yes, 0.863. So what y'all got? Good. That answer your question about this one? That one was tough. Tough just because you got to go through so much just to find the height so that you can find the area. Y'all look sleepy. What else? All right, Avery, which one did you ask about? You said don't do before. No, I didn't do this. I must have at some point. Oh, sorry. Okay. A solid perpendicular to the x-axis squares volume of each base. X minus 4, 4 minus x. Perpendicular to what I say? X-axis. Okay. X minus 4 is positive slope, intercept at 4, intercept 4. All right, what's my shape? This is 4 minus x, this is x minus 4. Squares, we like squares. Cross section, so I'm looking at this being the cross section. That's still perpendicular to the x-axis. It doesn't stop at the x-axis, it goes all the way through, it's still perpendicular. That distance is still going to be top minus bottom. The side of the square. Remember, the area of a square is side squared. One side is 4 minus x.
Why is it top minus bottom?
Minus x.
Would it be half of top?
No, think about it. So if this, let's say this point happened to be, I don't know, 2, and this was negative 2. What's 2 minus negative 2? 4. It's still giving you that distance between. That works. That takes into account negatives and everything. It always, always, always works. All right, so this ends up being negative 2x plus 8. So that means the area of a square is negative 2x plus 8 squared. What am I integrating from? 0 to what? 0 to. They intersect at 4? Yeah, sure. Right here is 4. Yes, that's right. All right. Let's check. Check. Okay. No. Okay. Negative 2x plus 8 squared dx. You could do a little u sub if you did this by hand. Well, we were going to do some revolutions, same kind of thing. Everything we do from here on out is the same concept. It's just adding a little bit more to it. Instead of pulling out cross sections, we take the cross sections and rotate them around the axis. I do have a visual for that for you, though. You're welcome, if I can find it. Okay. Negative 1/2 times 1/3 u cubed from 0 is going to become 8. What? Oh, does it? Oh, okay. What do you get when you use a calculator? Y'all just really like to rain on my parade. It confuses you when I evaluate. Okay. What do you get when you plug them in? Still got the right answer. Yeah. X squared plus y squared equals 100. That's a whole circle. A whole circle as opposed to a half a circle. Your graph, let me tell you why. This is another geometry concept y'all should have gotten in geometry. This is the parent, oh no, this is the equation of a circle with a radius of 10. So it's x squared plus y squared equals r squared. That's the equation of a circle. So that gives you the whole circle. Here's why. If you solve this thing for y, okay, I'd get y squared equals 100 minus x squared. Then I'd take the square root, right? And it's plus or minus. That's exactly right. There's the plus. That's your semicircle you were graphing earlier. Remember the square root of, I don't remember what it was, 2 minus whatever. And then the minus would be the one below, right? Okay, so how do we do that? What I would do, okay, what did it say? It said, this is negative squares, and this is square root of 100 minus. I would say that the side length on this one, again, remember, when you do top minus bottom, it takes all that negative into account. So you got top minus the bottom, or if you saw that and you could look at it and say, oh, but they're the same, so it's actually 2, because this is like plus, right? There's 2 of these 100 minus x squared lengths. So for the area, all I have to do is square that, which would be 4 times 100 times x. And now integrate. It said, y'all said it was the same directions. I didn't go back and look. Yeah. All right, you put it in your calculator. I'll do it by hand. Let's see who gets there first. No, go ahead, Lainey. What you got? This one might take a little bit longer. 12 minus 4 is 8,000 over 3 minus. I got some in the closet. Go look in my closet. There's an open box. That's right. No, look on the other side. You did get that or you didn't? See the open one? Yeah. Not on that. Yeah, that's fine. Just square both of them. What else? What else? What else? 13. X squared minus 4, y equals 4. That's it, yeah.